No.
Not it.
It's visible now?
Yeah.
Yes, sir.
Yes. So EIGRP is not a bad protocol. EIGRP is also amazing protocol, but this is for Cisco network. EIGRP was Cisco proprietary protocol earlier. Right? Even today, many vendor devices doesn't support EIGRP. So one issue with EIGRP is it is a Cisco protocol, right? Even Cisco has declared it as open standard, but many vendor doesn't support. Now you can imagine in your enterprise network, there are some Cisco devices in headquarters, some Juniper devices in data center, some Palo Alto firewall, some Arista switches. In that case, you cannot go with EIGRP protocol. Otherwise, you have to configure lots of redistribution. And when we configure again redistribution, we need to apply the policy using route map. We need to filter routes. We need to perform tagging, and we also need to take care of routing loop. That is one issue with EIGRP, right? But still you will find EIGRP in the production, like in a small to medium size network, in Cisco network, in old network, legacy network, over DMVPN. So EIGRP is still running in real-time network, but it's not, it has limitation in multi-vendor environment, and OSPF is an open standard protocol. So every major vendor support it. And second issue is, one was with vendor. Before talking about OSPF, let's understand some limitation of EIGRP. Right? Otherwise, you guys are going to think EIGRP is not a good protocol, it's a bad protocol. That's why we replace EIGRP with OSPF. No, it has limitation. Even OSPF also has limitation. That's why we have what? BGP. We have BGP for stability when we need to exchange thousands and thousands of prefixes between two companies, between two countries, between two cities, between two data center. We'll go with BGP. Between customer and provider, we are going to use BGP protocol. Inside the companies, OSPF. Similarly, in some cases, EIGRP is better than OSPF. In some cases, EIGRP is better than OSPF and BGP because CPU consumption is less in EIGRP as compared to OSPF. But it is not good protocol in multi-vendor environment when we have devices from different vendors: Cisco, Juniper, Palo Alto, Arista, Nokia, HP, and so on. Second limitation of EIGRP protocol is scalability. Now imagine if your network is large. Imagine if your network is large. In your network there are around 300 branches, right? Let's say 10 data center. Right, and thousands of routers. In this case, if you are going to enable EIGRP protocol, what happens? All the routers will have large topology table, large routing table. All the routers will be in same autonomous system, which will create a large database. Right? So in large network, EIGRP is not scalable as OSPF. Why OSPF is scalable in these kinds of large network protocol? Because OSPF introduces area concept. Right? You can logically group, you can logically create multiple section in OSPF. In one section, in one area, you can have 50 routers, 10 routers, which can limit the database size, routing table size. Like we come up with subnetting. Why we come up with subnetting? To divide large size of network into multiple smaller subnetworks. Benefit: easy management, easy to implement security for any department, easy to troubleshoot the issue when someone is not able to access services, not able to access network. So EIGRP is not as scalable as OSPF. In this kind of scenario, like in large network, medium to large size network, we will always go with OSPF routing protocol. So one benefit of OSPF is multi-vendor, right? Almost all major vendors support OSPF routing protocol, and OSPF is more scalable than EIGRP. In this case, EIGRP is not scalable. Otherwise, all the routers should be in same autonomous system number. If you will create multiple EIGRP ES, then you need to configure redistribution, right? You will avoid redistribution in production. Few redistribution is fine. You can redistribute OSPF into EIGRP, EIGRP into OSPF, EIGRP into BGP, BGP into OSPF. But you cannot configure hundreds of redistribution on the router. It can cause issue, it can cause the loop, it can increase the CPU of your devices. Even in EIGRP, we have many other features, right, to reduce the database size. Like we can use summarization technique, we can use route filtering technique, right? But it will be difficult. It's difficult to manage EIGRP protocol in large network. The next reason can be like control. If I will talk about the control, as I said, OSPF introduces area boundaries. So in OSPF, you will have better control as compared to EIGRP in large network, right? Because of area boundaries, right? And again, in OSPF also we have features like route summarization. We have multiple types of area: stub area, totally stub area, NSSA area, LSA flooding, DR and BDR, right? These are the features of OSPF you will experience. So OSPF is better protocol in multi-vendor environment when you have Cisco, Juniper, Huawei, Nokia, FortiGate, Palo Alto, right? And so many other vendor devices. These are the limitation of EIGRP. But the good thing about EIGRP is it uses less CPU as compared to OSPF. When you will understand the working of OSPF, you will get to know. OSPF is a link state routing protocol. Can anyone tell me the meaning of link state routing protocol? What is link state routing protocol? Link state.
Sir, it's basically to do with the bandwidth of the link to which the devices are connected.
EIGRP is also using link properties to calculate the metric, bandwidth, delay. OSPF is also going to use the link bandwidth. Yes, that is one link properties. It is similar. But EIGRP is not fully link state routing protocol.
So it's a hybrid, if I'm not wrong.
EIGRP is a hybrid routing protocol. Yes. See, link state routing protocol means link state routing protocol doesn't exchange routes. Link state routing protocol advertise link information. Like if I will talk about EIGRP protocol between two routers, let's suppose I have R1, R2, and on R1 I have some LAN network. On R2 also I have some LAN network like this. R1, R2. Let's suppose here we have two LAN 10.1.1.0, 10.1.2.0. and 10.1.2.0/24. Here behind router number 2, we have, let's say again, two network. 20.1.1.0/24, 20.1.2.0/24. You all know here subnet is 12.1.1.0/24. You all know if my routing protocol over here is EIGRP between R1 and R2. If I have enabled EIGRP on all interfaces on router number 1 and all interfaces on router number 2, then how routers are going to exchange routes? How router 1 is going to learn these 20 networks, how router 2 is going to learn these 10 networks, right? So router 1 is going to advertise their all network information to R2 with the help of update message. It will generate an update message. In this update message, it will carry what? 10.1.1.0/24 and K values. so that R2 can calculate metric 10.1.2.0/24 and K values, so that R2 can calculate metric for both the subnets. Similarly, R2 is also going to advertise one update message to R1, and that update message will carry these two prefixes. From the topology table, first EIGRP is going to build topology table. It will install both prefixes in topology table. It will calculate the FD and RD. And after that, through update message, it is going to advertise all the prefixes which are present in routing table except the subnet which is running on exit interface. Correct? It will advertise all prefixes from the topology table except the prefix which is running on exit interface. But if I will talk about OSPF routing protocol, OSPF is not going to work like this. Link state routing protocol means routers are going to advertise the link information. Let's say this is 0/0 interface, this is 0/1 interface, this is 0/2 interface. Now, as soon as you will enable OSPF over here, router 1 will maintain a database. Will start maintaining a database. In database, router store LSAs. Link state advertisement. This is similar like your EIGRP update message. And we have multiple types of LSAs. Total 12 types of LSAs are there in OSPF. If I will talk about first LSA, right, I'm not talking about types of LSA for now. Imagine database only, database of R1. So in the database of R1 or in the LSA link state advertisement of R1, it is going to keep information like this, that I have a link number, let's say 1, and the subnet which is running on my link 1 is 12.1.1.0, right? Subnet mask which is running on this link is 255.255.255.0, right? Cost of this link is, let's say, cost of this link is, let's suppose 10, right? Then link network type of this link and some more information. You will experience that, right? No worry. Then other link information, link 2. On link 2 my subnet ID is here. I can copy, paste link 2. In links 2 my subnet which is running over here is 10.1.1.0. subnet mask is same, cost is, let's say, 15, right? It is going to calculate the cost, whatever cost it will calculate. Then link 3, on link 3 my subnet which is running is 10.1.2.0 and some other information. This is called link state advertisement. This is OSPF database. And all the routers are going to use a router ID concept, right? All router will have one router ID which is used to represent their database. Like this is the database of 1.1.1.1, and router 1 is going to advertise this LSA to their neighbor. Router is going to advertise this LSA to their neighbor. So if I will talk about the database of R1 and R2, in database of R1 we will have two router LSA, one LSA of R1 and one LSA of R2. Similarly, in the database of R2 there will be two LSA of R1 and LSA of R2. And inside the LSA you can see detailed information of links. So a router can view the entire topology. By looking into the topology table, a router can know the entire topology. It is like Google Map. If you want to go to B point from A point, whatever option you have, you can view and you can select, you can choose the best one. It is like that. But EIGRP is not like this. In EIGRP, routers are still dependent on their neighbor, because in EIGRP, router receive an update message. So router only know that, okay, if I have a prefix, I'm getting one prefix 10.1.1.0 and next hop is 12.1. It is coming from 12.1. That's it. That's it. That's why whenever successor goes down in EIGRP, router generate what? In EIGRP, when successor goes down, router generate
query message.
Right? And you know the issue with query message. If router has generated a query message, router should receive reply message within 180 seconds it should receive the acknowledgement. Otherwise, you know the issue. Why router need to generate query message? Because EIGRP don't know about the topology. EIGRP only knows successor and feasible successor, but OSPF can know the entire topology. That is the meaning of link state routing. 1 minute, guys. So link state routing protocol doesn't advertise routes. Link state routing protocol advertise link information. And with the help of link information LSA, router can view the entire topology. That is the benefit of OSPF. Then there are so many other benefits, like as I said, OSPF introduce areas. Through area, you can divide your large network into multiple smaller networks, a smaller section, a smaller part logically, right? That will help you to manage the database routing table effectively in large networks. Okay, so very first thing is link state routing protocol. Link state routing protocol will have the information of entire topology. For an example, if this is my topology, if I am going to enable OSPF over here, then you can verify the database of OSPF routing protocol. As soon as I will enable OSPF routing protocol on any link, it is going to store that link information in their database. In database, router can have multiple LSAs. Right, as I said, there are 12 types of LSAs. You will understand all types of LSAs one by one. Right, first we'll understand the router LSA, then we'll understand network LSA, summary LSA, and so on. So for an example, this is my router interface F0/0, no shutdown, and IP address 12.1. Tell me, as soon as I will enable EIGRP protocol on this interface, what happened first? What happened first? Tell me the very first thing which will happen on the router as soon as I will enable EIGRP over here. Like if I'm going to say router EIGRP 10 and network 12.1.0.
It will look for router ID. So means once this command is given, it will EIGRP will be enabled on that interface, and it will look for the router ID.
So when
No, it will join the multicast group.
very good. Right, in EIGRP we don't have any significant of EIGRP router ID. Even you can configure the router ID, you can ignore it as well. Two routers can have same router ID, because router ID is not used to represent the topology table. Even router doesn't exchange router ID information with their neighbor.
Okay.
So as soon as I will advertise 12 network in EIGRP, my interface is going to join a multicast group. And as soon as the interface will join the multicast group, it will start sending a hello message to discover neighbor on that interface. Do so IP interface F0/0. Here you can see it has joined this multicast group 224.0.0.10, which is reserved for EIGRP. Okay, and router EIGRP command, what this command did here, router EIGRP number 10 just allocated some memory for EIGRP process, right? Nothing else. EIGRP is after hitting enter over here, EIGRP is not running anywhere on router number 1. Just you have allocated the memory. In same way, when I am going to run command router OSPF and 1 process ID 1, see, on single router you can run multiple process of OSPF. We can have multiple OSPF process on single router. That's how we have process ID concept. And like we have router ID EIGRP router ID concept in EIGRP, but there is no any significance with neighbor. Similarly, process ID has no any significance in OSPF. neighborship. Router are not going to share process ID. You can configure process ID 1 on router number 1, process ID 2 on router number 2, same or different, doesn't matter. Router are not going to exchange process ID. This is just to identify the OSPF process on local router, right? Because we can enable multiple OSPF process. So let me say process ID 1 here and network 12.1.1.0 wildcard mask 0.0.255 and area 0. This is how we enable OSPF on any interface. Right, in EIGRP, you can run network command without subnet mask. You can advertise network with subnet mask as well as with wildcard mask. In OSPF, you can only advertise prefixes with the help of wildcard mask. So first my command is same network, then the subnet ID, after that wildcard mask, which is mandatory on OSPF, and then area. Right now we are talking about single area, so just keep in mind area 0 every time we are going to advertise prefixes in OSPF area 0. And after hitting running this command, if I will verify the interface has joined any multicast group or not, then you can see this interface has joined one multicast group, that is 224.0.0.5. Right, in OSPF we have two multicast group, and now router will start sending hello message from here. If I will debug IP OSPF hello, and you will see router will start sending hello message. Maybe line protocol is down, so here on F0/0 I am going to say no set and IP address 12.1.1.2255255.255.0, so that line protocol can come up. You can see now on router number 1. Right, router 1 is sending OSPF hello message. OSPF process ID 1 hello message from fast Ethernet 0/0 send hello to this multicast address 224.0.0.5 in area 0 from 12.1 source. So router 1 is trying to discover the neighbor over here on this interface fast Ethernet 0/0, but it is not listening any hello message, right? Not receiving any hello message over here. So on all. So IP OSPF interface brief. You can see OSPF is enabled on fast Ethernet 0/0. The state of this interface is DR. We have DR and BDR concept in OSPF. Soon you are going to learn that as well. This is the IP address which is running on my interface. This is the area ID information. This is the process ID. But the most important, and this is the cost value, the cost on this link. How OSPF is calculating the cost? Soon we are going to discuss the formula as well. So IP OSPF database. See, inside the OSPF database there is one SLA. This is called what? SLA. Router LS. Router LSA. Link state advertisement. And how many links are there inside this router LSA? 1. If I am going to add one loopback here, interface loopback 1 and IP OSPF 1 area 0. This is another way to advertise any interface in OSPF. IP address 10.1.1.255.255.255.0 and IP OSPF 1 area 0. This is another way to advertise any interface in OSPF. Through network command also we are enabling EIGRP on the interface. In OSPF we have feature to enable OSPF directly on interface basis. Now OSPF is enabled on two interfaces. So IP OSPF interface brief you can see, and so IP OSPF database. In database you can see still we have only one router LSA, but now how many links are there inside that LSA? 2. And when R1 is going to discover any neighbor, it will advertise this SLA to their neighbor. And you know their neighbor can know what? You can open this in detail. Router LSA and 12.1.1.1. You can see what informations are there inside this router LSA. Right? First of all, it is saying link connected to a stub network. A stub network means connected network. Network ID and subnet mask. Right? Number of metric cost value and link, another link connected to again a stub network, both are connected network, subnet ID and metric, number of link, and this is SLA header. This is SLA header. We will master the database of OSPF routing protocol, because you know OSPF is very important protocol, and you can only understand the protocol when you know how to read the database.
Sir, what will be the output? You gave the router ID as 12.1.
No,
What
this
will
is
be
not
the out?
router ID, no, bro. This is
Sorry,
link ID.
IP address. IP address. So,
Link ID,
what
link
if you
ID.
give the loopback IP address instead of 12.1 in
No,
that
no.
command?
We open database with the help of link ID.
Not with the loopback ID.
No.
Okay. Thank you. Sir, just in case if there is a LAN interface on the other side of or LAN interface on that router, will this command work for that interface IP address or only WAN
Yes,
IP?
yes. No, it will work. See, there are two things in, you will find two things in every SLA in OSPF database: advertising router ID and link ID. And you will always open your database in detail with the help of link ID. In this SLA, link ID and advertising router ID is same, 12.1.
One.
But it is not mandatory that in all other SLA also advertising router ID and link ID is going to be same. Sometime link ID will be the router ID of router, sometime link ID will be the IP address of router.
Okay.
Advertising router ID will be every time router ID of router who is advertising that
Okay.
SLA. Now let me take you to router number 2. And here also I am going to say IP OSPF1 area 0. Area should match, then only two routers can become neighbor. And so IP OSPF neighbor. So IP OSPF neighbor. Now my neighborship is in full state. Even we have OSPF neighborship state, and you can see who is neighbor, 12.1. And now if you will check database of R1, so IP OSPF database, you can see how many SLAs are there in database. 2 router LSA, one of R1, one of R2, and one more SLA is added, that is network LSA. So this database is so powerful. With the help of database, router 1 can know everything, each and everything about the topology. Router 2 can also know each and everything about the topology, and database is going to be identical, same. Either I am checking the database of R1 or R2, you will have exactly same information. So IP OSPF database. So IP OSPF database, you can see. Any difference in database of R1 and R2? No, both the database are exactly same. So by looking into the router LSA, R2 can understand that how many routers are there in the topology. Okay, 2 routers are there. R1 can also, two routers are there in my topology, right? One is router whose router ID is 12.1, and router whose router ID is 12.1 has how many links? 2 links. A router with router ID 12.2 has 1 link. It is like this. So link, this is the meaning of link state routing protocol. A router can view the entire topology. Each and every router will have information of complete topology within the area. So even OSPF is not fully link state routing protocol, guys. OSPF is a fully link state routing protocol within area. Between the area, OSPF and EIGRP both are same protocol. Between the area, OSPF also advertises prefixes like EIGRP advertise with the help of update message. Within the area, OSPF is link state routing protocol. Between the area, OSPF is also exchanges prefixes like EIGRP. Okay, this is link state routing protocol. Now let's understand few things about OSPF. First, OSPF stands for what? Tell me the full form of OSPF.
Open shortest path first.
Shortest path first. Guys, open means it is an open standard protocol, and shortest path first is an algorithm OSPF uses for best path selection. Like EIGRP uses dual algorithm. Similarly, OSPF uses SPF algorithm. In short, what you can say, SPF algorithm. SPF. Shortest path first. Shortest path first is an algorithm, like dual algorithm in EIGRP. So open SPF, open standard shortest path first protocol. Done. Next thing, it is an open standard protocol. Good. Next thing is it is an IGP protocol. OSPF is a IGP. What it mean? What is the meaning of IGP? Interior Gateway Protocol means it works within the autonomous system. Yes, right. And autonomous in OSPF is you are not going to configure the autonomous system like EIGRP. In EIGRP, we define the autonomous system number, router, EIGRP, and then ES number. In OSPF, automation is your area, right? With the help of area, we are going to represent our domain. The next thing is it is a link state routing protocol. It is a link state routing protocol. Link state routing protocol. You all know the meaning of link state now. Link state routing protocol means it is going to exchange database, LSDB, link state database. OSPF database is called link state database, LSDB. Then protocol number of OSPF is, it is a network layer protocol, works at network layer, layer 3. Means this protocol will not have any port number. It will have protocol number, right, for the encapsulation, and protocol number is 89. OSPF uses protocol number 89 for IP packet encapsulation. Next is multicast. Like EIGRP uses multicast address 224.0.0.10. Similarly, OSPF uses two multicast group. Multicast address 224.0.0.5 and 224.0.0.6. Like in my case here, you can see earlier router has joined fast Ethernet 0/0 of R1 has joined one multicast group 224.0.0.5. So IP interface F0/0. And now you can see this interface is member of two multicast group. Correct? Now this router is member of two multicast group .5 and .6. Okay, we'll talk about both the multicast address. These are two multicast address, and you can see my interface has joined both multicast group. One multicast group like 224.0.0.5 is used by, or you can say all the OSPF routers listen on this address. Listen by all routers, all OSPF router, and .6 will be only listened by DR and BDR. Now again, for some of you, what is DR, what is BDR, nobody will understand soon. And when you will understand DR, BDR, then remember this point. DR and BDR are two special routers in OSPF, and those routers listen on both address .5 as well as .6. Very important concept. Only DR and BDR. If some router, or let's suppose I have a network like this, I have some router R1, R2, R3 and R4. All the routers are connected with one switch. Means all routers are in same multi-access segment, in same broadcast domain. If some router is going to send a message, any message, it can be OSPF hello message, LSA, any message on which address, on .5, then all routers are going to listen. All the routers are going to accept, receive it. But if a router is sending any OSPF message on .6, then only DR and BDR router will listen. Let's suppose this router is my DR router, this router is my BDR router, and this router is my DR other router. So R3 is going to just discard it, because this router will not join .6. This router has not joined .6. It means someone is sending message to whom? To only DR and BDR. It is not for every OSPF router. If you have a message on .6, it means this message is only for DR and BDR. Please put yourself on mute, guys. Getting noise from somewhere. Yes, great. Thank you. Done. Now, how OSPF calculates metric based on SPF algorithm? First of all, before that, if I want to check that my router has calculated SPF algorithm how many times, can I check this? Yes, you can check this. You know, whenever EIGRP is going to perform dual algorithm, it is going to use their CPU only, right? So router should not perform algorithm again and again, should not recalculate the routes again and again, should not build the topology table, routing table again and again. If router is doing that, it means routing protocol is not stable. It's fluctuating, flapping. That's the issue. Because of your EIGRP neighborship link flapping, router CPU can increase and user can get poor experience. For users, application can stop working. So routing protocol should be stable. That's why many times I told you query message is not the good thing. It's a bad thing of EIGRP. Router should not generate the query message. Can anyone tell me how I can avoid the query message in EIGRP? Because guys, we have already discussed EIGRP protocol. We have talked many things about EIGRP, and we have also performed lots of lab. So meanwhile, I will be also asking you some questions from the previous topics. Like in next class, I can ask you questions from today class. So can anyone tell me how I can reduce number of query message on the router? Or a router in my enterprise network is generating lots of query messages. How can I avoid that?
By making neighbor
Stop. One, stop.
Okay, stop with one feature, but that is for border router only.
Root summarization.
Summarization also, sir?
Yes, summarization, and most important, at feasible successor. At feasible successor, perform summarization. Yes, good. So how many times my router has executed SPF algorithm over here to calculate the best OSPF route? So IP OSPF. If you are going to run this command here, it will show you two things. One is reference bandwidth. I'm going to talk about reference bandwidth now. And the second thing is SPF algorithm executed 3 times. So R1 has executed SPF algorithm 3 times. If any interface will goes down or come up, again it is going to execute SPF algorithm interface loopback 1 shutdown. And so IP OSPF. Now you can see it has calculated SPF algorithm. It's showing 3 only. And now it's showing 4th time. So 4th time router has selected the best path. What it means? It means router has selected best path 4th time till now. How SPF algorithm is working? So there is a formula to calculate metric. First of all, guys, metric in OSPF is called as cost. What do we call it? Cost. And formula to calculate cost is so simple. Formula to calculate cost is a reference bandwidth upon bandwidth of link. Reference bandwidth is clear with their name only. It's just a reference value to calculate the cost. Reference bandwidth divided by bandwidth of link. Formula is simple. Right? In EIGRP 10 raised to power 7 least bandwidth total delay 10 whole multiply by 256 bandwidth of link. So let's suppose a router has a fast Ethernet link. What is the bandwidth on fast Ethernet link in Mbps? Bandwidth on fast Ethernet link?
100, sir.
100 Mbps. Correct? And what is the reference bandwidth by default on the router? 100. So what will be the cost of this link? 1. Yes or no? 100 divided by 100. Reference bandwidth 100 divided by bandwidth of my link 100. That's why router has calculated what cost on fast Ethernet link, guys?
1.
But let's suppose on same router, if I have a gig link, 1 gig link, G0/0. What is the bandwidth of gig link?
1000.
1000.
Yes.
Now, what will be the cost over here?
10.
1, sir. 1.
100 divided by 1000, 0 point something. It is going to consider that as 1. So see,
1.
OSPF is not able to calculate or not able to differentiate the cost on fast Ethernet link and gig link. For OSPF cost, both links are same. But is both links same? No. How can I solve this problem? I can change my reference bandwidth. So by default, reference bandwidth is 100. Here, if I will set reference bandwidth 1000, then cost over here is going to be what? New cost. 1000 by 100. 10. And
10.
Cost over here is 1. So whenever you have a link with more than 100 Mbps, then you should change the reference bandwidth value. Default reference bandwidth value is 100 Mbps. This is OSPF cost calculation, metric calculation, right? So simple. Now, these are basic things about the OSPF. Now, types of messages in OSPF. Anyone have idea? We have total 5 types of messages. Type 1, type 2.
Hello.
Yes, hello. Then type 2 is what? Type 3.
Hello and hello DVD.
Okay.
DVD and LSR, LSU acknowledgement, LSAC.
Yes. First message, type 1 message is hello message. Type 2 message is DBD message, database description message. Type 3 message is LSR, link state request. Right? So see, even when two routers will become neighbor, router are not going to exchange the database like EIGRP. Once EIGRP is going to discover the neighbor, it will see their routing table. Here first router is going to generate LSR, link state request. And in the response of link state request, router is going to generate LSU, U, which is actual update message. And OSPF is also a reliable protocol. We have one acknowledgement message, similar like EIGRP, that is LS hack. These are 5 types of messages in OSPF. See, about these messages, what we need to understand, the first thing is, when router generate these messages, like you all know about the hello message. Hello message is used in any routing protocol. In any dynamic routing protocol, the hello message is used for dynamic neighbor discovery, DND, and keep alive. There are 2 functions of hello message: neighbor discovery, dynamic neighbor discovery, and keep alive. So here also OSPF hello message is used for DND and keep alive. And router always send hello message on multicast address. Right? In case of a static neighborship, again unicast, similar like EIGRP. On multi-access segment, on multicast address 224.0.0.5 or 6. 5. Because all OSPF routers are listing on 5 only. Right? Because in many time you will not have any DR and BDR in your network. Right? DR BDR is required in a specific scenario in broadcast network when we have more than 2 routers. So hello message on 224.0.0.5 and unicast in case of static neighborship. And if I will talk about the content of hello message, contents, then very first content is going to be version, which version of OSPF is running. Then types of message, type is 1. This is type 1 message. Length of message and router ID. Very important. Router ID play big role in OSPF. After that, see, there will be some fields like version, length, checksum, and I am not going to talk about those fields. I'm going to talk about those fields, those contents which matter for neighborship, which we need to learn. So apart from the type of message, router ID, there will be information about subnet mask. And subnet mask must match. Right? This is also one OSPF neighborship parameter. Then hello time and dead interval. Hello and dead interval, which should again match. Then priority. After that, DR router information, DR router ID, BDR router information, BDR router ID. Then there will be neighbor router ID information, neighbor router ID. Then authentication, like when you will configure the authentication. If authentication is configured, then authentication type and authentication data. See, if you are not speaking, I will request you to keep yourself on mute, bro. There is noise. Lots of students are there, and even it will be difficult for you to watch recording later. If you miss something over here, you are going to watch the recording later. And if there is noise, it will be difficult for you to watch the recording. So these are the content of hello message. And if I will talk about the parameters, guys, neighborship parameter, then first parameter is router ID. Router ID must be
same.
Unique.
Must be unique,
Unique on this one. Yeah.
right? If two router has same router ID, then OSPF neighborship will never come up.
Yes, yeah. I just got confused with that EIGRP. Sorry.
No. In EIGRP, it can be same, it can be unique,
Yeah.
right? There is no any
Yes.
significance of router ID in neighborship in case of EIGRP.
Yeah. Got it.
But what I told you, OSPF represent their database with the help of router ID only. Even you have seen that.
Yes.
Router has a store LSA with the help of router ID only. Done.
Yes.
Subnet mask must be same.
Same only, sir.
Must be same. Hello time and date time must be
Same.
same. Then priority, no significance. Right? DR router ID, BDR router ID, these are going to be values. Right? Neighbor router ID for bidirectional connectivity. If you have configured the authentication, then authentication also must be same. And authentication type as well as authentication data, both should be same, must match. And one more thing, right? In OSPF, we have two types of neighborship: neighbor with adjacency, neighbor without adjacency. Earlier also I had given you the example. You must have experienced neighbor with whom you share food and everything. You talk a lot, and sometimes with some neighbor you hardly talk, right? So in OSPF also we have two types of neighborship. Sometime you will see router has neighborship, but router is not exchanging database, right? Only they knows that, okay, router 2 is my neighbor, but they don't have adjacency, they don't have exchange the database. When router has exchanged the database with neighbor, that neighbor will be called as adjacency, neighbor with adjacent, right? That neighborship state will be in full state. For that, it is going to check MTU size. MTU must be same. If MTU is not same, it doesn't mean two router will not become neighbor, because see, MTU is not part of my OSPF hello message, right? It's not the content. Router is not going to share MTU's information in hello message, right? So two routers can still become neighbor if MTU is not same, but they will stuck, neighborship will stuck in X start or exchange state. Soon you are going to learn the state as well, neighborship state. So MTU must be same. Through DVD message, routers are going to exchange the MTU in X start state. Soon you will learn in which state router are going to exchange which message. Apart from these all things, there are some more things which should be same, which should be unique for OSPF healthy neighborship, like network type. Till now maybe you don't know the network type, later you will learn the network type. Network type must be match, must be same, network type. And here
Excuse me, sir, there should be an area ID too, right? And hello content
yes,
package. Yeah.
area ID, yes. See, in this case I have not configured any network type, but what is my network type over here? I'm not able to see here, but I can open. So IP OSPF interface fast Ethernet 0/0. This is OSPF network type broadcast. And so in OSPF we have multiple types of networks, and it depends on link type. On the Ethernet link, every time OSPF network type is going to be broadcast. Our serial link, it is going to be point to point. Later we'll learn the network type. So network type must be same. And one more thing here, inside the OSPF hello message, there will be area ID information. I forget that, area ID. Area ID must be same. This is your OSPF neighborship parameters.
Sir, in OSPF, two type of neighborship are there, right? Full and partial. So MTU must match for both full and partial.
No, it's mandatory for full neighborship.
Full only, right? Okay, thank you.
You will learn this. Okay, no worry. Okay, so this is neighborship. If all are matching, then two routers can become neighbor. If MTU is not matching, two routers can stuck in some neighborship state. Now let's understand some parameter which you are not familiar, like router ID. Let's start with a router ID. Till now I have not discussed anything in OSPF protocol, guys. This is just an introduction. This is my first topic of OSPF protocol, which is router ID. Let's start. What is router ID?
So it's a 32-bit unique identification number for that device, network
Very
device.
good. Very good. It is a 32 bits decimal number represented in IPv4 format. Like you know, IPv4 is also what? 32 bits decimal value represented in dotted decimal, and we have 4 fields. We separate each field by dot. So in same format we represent the router ID as well, right? So it is a 32 bits a unique identification of OSPF router or of a router database in OSPF domain. Question is how router elects router ID. Anyone?
With three ways: manually configured. If there is a not manually configured, it's gonna take the highest loopback interface. If we have configured the loopback interface, if there is no loopback, then it's gonna take the highest active physical interface, right? IP.
Okay, good. Thank you. See, the first way is you can manually define the router ID. On the router, I can say, hey R1, your OSPF router ID is 1.1.1. Here R2, your OSPF router ID is 2.2.2. But if you will not define the router ID manually, then router is going to elect it dynamically, automatically. Dynamic. Static method, manual method, and dynamic method. Can anyone tell me, let's suppose I have a router. And this router, on this router, I don't have any loopback, and I have not configured IP address on any physical interface even, but I have enabled the OSPF. In that case, what router ID router 1 is going to use?
Zero.
Yes,
No, it
0.0.0.
usually we see as error message also, right? That no router ID, like we are not able to configure.
You will get the error message, and router will start using 0.0.0.
Okay.
And I'm requesting to those students who are repeating, right, the OSPF protocol or your batch, to not answer quickly, right? Let's answer to new students, whoever are joining the batch, OSPF batch for the first time, right? And when no one is answering, then you can try. Okay?
Thank you very much, sir.
Welcome. Okay, so see, as if I don't have any router ID, let me do one thing here. On router number 2, I am going to say no router OSPF 1 and interface F0/0, no IP address. Now here we don't have any IP, do so IP interface brief, nothing. And router OSPF 1. Now it is giving me the error, you can see. OSPF process 1 failed to allocate unique router ID and can't start. But if you will check so IP protocol, you can see OSPF is enabled and router ID is 0.0.0. But guys, OSPF cannot work with router ID 0.0.0. This is a unknown router ID. It cannot build database. So IP OSPF database, it cannot build database because not running because of router ID. Okay, so if you will not configure the router ID manually, router is going to look up loopback interfaces IP address. If you have multiple loopback on the router, then highest IP address on the loopback interface. For an example, on this router I have two loopback 1 and loopback 2. On loopback 1 my IP address is 1.1.1. On loopback 2 my IP address is 2.2.2. right? So highest loopback IP address will become router ID of R1. 2.2.2.2 will be the router ID of R1. Highest loopback IP. And if loopback doesn't exist on the router, then router is going to check physical interface IP address. Again, if router has multiple physical interfaces where IPv4 address is running, it is going to check highest physical interface IP address, and that will become router ID. Highest physical interface IP. And if IP address is not running, we don't have loopback, we don't have any physical interface, then 0.0.0. This is router ID election. Is it clear?
Yes, clear.
Right, like here on router number 2, if I will create one loopback interface, loopback 1, IP address 1.1.1, 255.255.255.255, and do so IP protocol. Router ID of router 2 is 1.1.1. If I will create now another loopback 2, IP address 2.2.2.2, 255.255.255.255. Now tell me what should be the router ID?
Sir, it's going to be 1.1.1 only.
No.
Right. Yes.
Yes.
Yes. Once router ID is elected, it is not going to change the router ID. Right. And once router, right now even you are allowed to change manually. I can say router OSPF 1 and router ID 2.2.2.2. See, I'm able to change. But once router will discover the neighbor F0/0, no shutdown, IP address 12.1.2, 255.255.255.0, and IP OSPF 1 area 0. Right, soon it will become neighbor. So IP OSPF neighbor. Now you can see neighborship state is in access start state. Right, DR/BDR election is happening. Now it is in full state. And now on router number 1, if I will try to change the router ID, router OSPF 1 and router ID, let me say 1.1.1. See, it is giving me the error. Why it is giving me the error? It is asking me to reload the OSPF or clear the OSPF process. Reason, router 1 has already shared their database to their neighbor. Right, R2 already has R1 database. So IP OSPF database. And in that database, router 1 has here what router ID? 12.1.1. And now you are asking R1 to change the router ID. That's why router 1 is not allowing you to change, because database is already exchanged. So if you want to change router ID on router number 1, you can clear the OSPF process, do clear IP OSPF process and say yes, and then say router ID to 1.1.1. Now you can see I'm able to change. And now if I will check so IP OSPF database, now you can see in R1 database we have two router LSA. One belongs to 1.1.1 R1, one belongs to 2.2.2 R2. In R2 also, so IP OSPF database, we have two router LSA, right, with same router ID. So if loopback doesn't exist, then physical interface IP address will become router ID. Better is you can set router ID manually, because you guys are learning OSPF right now, and router ID is going to help you a lot to check database, to understand the database, to read the database. and it's all about database only. If you want mastery, if you want to do mastery in OSPF routing protocol, you have to read OSPF database properly. If you know each and every words inside the database, you can understand the problem and you can fix it. Done. So first thing which we have discussed over here is a router ID, and second thing which we have discussed over here is hello message, because hello message behavior is exactly same like OSPF. Now, before understanding how two routers are going to become neighbor, understand something more important than neighborship, which is neighborship state. So that together we will discuss both how two routers are going to become neighbor, as well as state, as well as types of messages, so that you can understand in which state router, OSPF router exchange which message. So one more thing over here, which that is OSPF neighborship state. OSPF neighborship states. See, we have total 8 states in OSPF. Number 1 is down state. Number 2 is init state. Number 3 is attempt state. Number 4 is two-way state, and this is one neighborship, right? If two routers has neighborship till two-way state, means this is neighborship without adjacency. As I told you, there are two types of neighborship. Good neighbor means full neighborship, to whom router has already exchanged entire database, and one in two-way state, to whom I will never exchange database, only we know each other, that's it, two-way. So if two routers are in two-way state, it doesn't mean there is some issue, right? This is a behavior, right? Routers can have neighborship till two-way state as well. The next is X start state. Sixth one is exchange state, and seventh one is loading state, and eighth one is full state. These are neighborship states, right? And I'm telling you this again and again, neighborship in OSPF. Number 1, neighbor without adjacent, right? Means till two-way. And number 2 is neighbor with adjacent, full, right? So in OSPF, two routers can have neighborship till two-way state or till full state. Either my neighbor can be in full state or my neighbor can be in two-way state. If neighborship is in any other state, in init, attempt, X start, exchange, loading, it means there is some issue. Yes or no? If neighborship is in any other state except two-way and full, that is issue. If there is any issue with the hardware, or with the port pin, or with the CPU, many times you will experience that neighborship is stuck in loading state, right? But this is very rarer. Hardly you will experience that neighborship is stuck in loading state. You will experience neighborship is stuck in X start state, which is very common. In exchange state also common, but not in loading state, but it can stuck in any state. Let's understand all the states now one by one. Let's suppose I have two router, R1, R2. R2. Let's say router ID on R1 is 1.1, router ID on R2 is 2.2. IP over here is 12.1. IP over here is 12.1.1.2. Let's suppose on router number 1, I have configured OSPF, router OSPF 1, router ID 1.1.1, network 12.1.1, while comma 0.0.0, area 0. What I mean, this interface is going to join the multicast group 224.0.0.5, and router will start sending type 1 message, which is hello message. So router is sending hello message, but router is not receiving any hello message on this interface. Let's say this is F0/0 interface, fast Ethernet 0/0 interface. Right, from F0/0 router is sending hello message to discover the neighbor, but it is not listening any hello message over here. No hello message received over here. That is the meaning of down state. Down state doesn't mean your interface is down. It means you have just enabled the OSPF and router has not received any hello message yet. Means process is started, router has started sending the hello message, and now it is about to receive hello message. If router 2, if you have enabled OSPF on router number 2 also, and state is showing down, it means there is issue. It means router 1 is not receiving the hello message. As soon as router is going to receive hello message from R2, means on this interface, as soon as router 1 is going to receive hello message on this interface, state will move from down to init. Down to either state will either move from down to init or attempt. Either in init or attempt. In this case, in init state, attempt is only for static neighborship or for NBMA. Later you are going to understand the OSPF network type. Non-broadcast multi-access network type is one type of network in OSPF. So in case of non-broadcast multi-access segment, you will experience this neighborship state attempt, or in case of a static neighborship, you will experience this state attempt. Otherwise, every time you will have init state, down, and after down init, after down init. So once router 1 will receive hello message on this interface, neighborship will move from down to init. Init stands for initialization. Means router is now initializing the OSPF neighborship. Done. Good. Init. In init state, router 1 is sending hello message. Router 2 is also sending what? Hello message. Router 1 has received the hello message of R2. Both the router has received hello message. Neighborship is in init state now. First it was in down, and now it is in init. And in case of static neighborship or non-broadcast multi-access, attempt. Instead of init, you will experience attempt. Next thing is now routers are going to check bidirectional connectivity. See in the hello parameters what I told you. like, sorry, in the content of hello message, where it is here. In the content of hello message, you can see one thing. There is information of what? Neighbor router ID. Neighbor router ID. But in the first hello message, which router 1 has sent to router number 2, can router 1 put the neighbor router ID? No, because router 1 don't know what is the router ID of R2. But now in next hello message, after receiving hello message from router number 2, in next hello message, R1 can see here their router ID as well as their neighbor router ID. In this hello message, router 1 is going to say, hey, my router ID is 1.1.1. Router 2 is going to say, hey, my router ID is 2.2.2. Now router 1 knows the router ID of router 2, and router 2 knows the router ID of router 1 is 1.1.1. So in next hello message, router 1 is going to say, hey, my router ID is 1.1.1 and my neighbor router ID is 2.2.2. Similarly, when router 2 will send hello message, router 2 is going to say, my router ID is 2.2.2 and my neighbor router ID is, sorry, my router ID is 2.2.2 and my neighbor router ID is 1.1. Like here, if I will capture this link, see, router 1 has started sending hello message. Source IP 12.1, exit interface IP, destination IP 224.0.0.5. If I will open it, and here you can see IP header, Ethernet header, and actual OSPF hello message. If I will open OSPF hello message, here you can see OSPF hello message header, which include version, type of message, type 1 message, hello message, length, router ID, my router ID, area ID, checksum, authentication type is null, authentication data is null. OSPF hello packet, subnet mask, hello interval, right? Priority, dead interval, DR router, BDR router, and some other information. Is there any information of neighbor router ID anywhere?
That source OSPF router.
Because router 1 has not received any hello message on this interface yet. It has not received any hello message on this interface yet. That's why on router number 1 even, if you are going to check neighborship, you will not have anything. So IP OSPF neighbor, you can see. So IP OSPF interface brief. Here you can see OSPF is enabled on fast Ethernet 0/0. This order become DR. I will discuss DR and BDR very soon. And so IP OSPF interface fast Ethernet 0/0. Here you can see the detailed information of your OSPF configuration. Now what I am going to do, now I am going to enable OSPF on router number 2 also. Router OSPF 1 and router ID 2.2.2 and network 12.1.2 0.0.0 area 0. See the first hello message of R2 here. This is the first hello message of router number 2. In this hello message is the information of neighbor router ID. Only source OSPF router ID is there. And in next hello message, here you can see after receiving hello message from R2, R1 is sending this hello message. In this hello message, you can see neighbor router ID, active neighbor information. This is router ID of my neighbor router. Now this is bidirectional connectivity. When router 2 will see this, that hey, oh, now router 1 is sharing my information as well. Router 2 will get to know that router 1 is already knowing about me. Router 1 is already knowing about me. This is my router ID, and router 1 is saying 2.2.2 means it's me. I am his active neighbor. This is bidirectional connectivity. Once router will find their own router ID in hello message, state will move from init to two-way. Two-way means bidirectional connectivity is checked. Means router has seen their own router ID in active neighbor field. Very good. Clear? Down, init, and then
Sir, can you repeat, sir? It's the two-way. It's the router one will see the on router ID.
both
Like
router will
R1
see,
will
yes. In the next hello message, R1 will see their own router ID in active neighbor field. R2 will see their own router ID in active neighbor field. Right, like this. You can see R1 is sending hello message and saying my router ID is 1.1 and active neighbor router ID is 2.2.2.
And up to that, it's in its state, right?
Yes.
Okay.
So can you move on the this wire, sir? Just a check. Just a quick check.
What? What you will check here? Tell me.
The router ID is the R1. This one is R1 capture. No? This one is correct. Okay, active
And
neighbor.
here is the hello message of R2. R2 is saying my active neighbor is 1.1.1. My router ID is 2.2.2. Okay. Now in two-way state, bidirectional connectivity checks happens. And one more thing happen now. When routers are in two-way state only, routers are going to perform DR and BDR election. In two-way state, routers are going to perform DR and BDR election. When bidirectional connectivity checked, now router will elect DR and BDR. It is similar like Prime Minister election. Like voting is going to happen between router 1 and router 2. One router is going to win the election. The router will win the election will become DR router. But before understanding the election, we need to understand why DR and BDR is required. In this case, guys, between R1 and R2, DR and BDR is not required. If router is selecting DR and BDR, like here you can see, as we have DR and BDR, so IP OSPF neighbor, what it's saying, my neighbor is DR, router 2, and router 1 is saying my neighbor, so IP OSPF neighbor, so IP OSPF neighbor, my neighbor is BDR. And because of DR and BDR, so IP OSPF database, we have this one more SLA in database. But DR and BDR is not required in this case. What I can do, I can avoid it. I can go to interface F0/0 and say IP OSPF network point to point. On router number 2 also I'm going to say interface F0/0 IP OSPF network point to point. That's it. Now if you will check, so IP OSPF neighbor, so IP OSPF neighbor, we don't have DR and BDR information now. On router number 2 also, so IP OSPF neighbor, you can see. And now if I will show you the database, so IP OSPF database, you can see one LSA is filtered from the database. Good. It's good. Even some engineers did mistake over here. This is the actual way to avoid DR and BDR. No to this. And on router number 2, no to this. By mistaken, because soon you are going to learn one more way to avoid DR and BDR. If you don't want router to participate in DR and BDR election, then you can configure priority 0. By default, priority is 1 over here. If I will say IP OSPF priority 0, then this router will not participate in DR and BDR. When I change the network type point to point, then DR and BDR is not required. But when network type is broadcast, which is default, then DR and BDR is required. And when DR and BDR is required, in that case, I have removed R1 from the election. Now R1 will not participate in DR and BDR election. So IP OSPF neighbor. Here you can see what it's saying. 2.2.2 is DR router. 2.2.2 is DR router. and on router number 2 show IP OSPF neighbor. 1.1.1 is DR other. If I will configure priority 0 on router number 2 as well, interface F0/0 IP OSPF priority 0, because I don't want DR and BDR over here. So let's set priority 0 on both the routers, so both the router will not participate in DR and BDR. Then no one will become DR and BDR. No one is going to become DR. And see now, so IP OSPF neighbor. Now your neighborship is stuck. Now routers are not going to exchange database. This is issue. Praful, you said two routers can be in two-way state as well. That is the behavior. That's not the issue. But guys, this time this is the issue. This time your neighborship is stuck in two-way state because of DR and BDR. When network type is broadcast, then at least one DR should be present. And here we don't have any DR and network type is broadcast. That's why routers are stuck in two-way state and routers are not going to exchange their database. Right, this is old entry. You can see the SLA time. Old entry. So IP OSPF database. Old entry. Clear IP OSPF process. Yes. And now you can see the database of R2. R2 has only their own LSA in database. And R1, clear IP OSPF process. Yes. R1 will also have only one LSA in their database. See? Both the routers are not exchanging. It means what? It means this is not the correct way to avoid DR and BDR between R1 and R2. Yes, this is not the correct way to avoid DR and BDR.
Sir, but why do we need to avoid DR and BDR?
Because it is not required over here. No? I said not DR and BDR is not required in this case. And soon I'm going to explain when DR and BDR is required. So first of all, let me correct it. Interface.
So why is it not required in this case?
First understand when it is required. Automatically you will understand why it is not required over here.
Okay.
Okay. So priority, first of all, I'm going to remove this command and then I will set network type IP OSPF network .2 point. On router number 2 also, interface F0/0. Now you can see again my neighborship come up in full state because now we have one DR. R1 become DR. Here also IP OSPF network, sorry, first priority 0 to no, and IP OSPF network .2 point. Done. All good. So IP OSPF database. Now you can see again database is updated. But why we have network LSA? This is again I think old entries. Clear IP OSPF process. Yes. And after this, so IP OSPF database, you can see we have only router LSA of R1 and R2. You will have same information in R1 database also. Now understand when DR and BDR is required. Let's suppose I have a broadcast network. I have some router. See, even earlier also I had given you this example. If I have 4 router, let's suppose in a headquarter I have 4 buildings. At each buildings I have one router. How should I connect these 4 routers so that my network is scalable? Directly link between the router, or I should use a centralized device over here like switch. For scalability, definitely you should use a switch over here. Let's suppose I have used this switch here in between, so that now I have lots of ports. I can even connect more routers. If hundreds of routers are there in headquarter, no problem. I can connect all like this. Good. Now all my router 1, 2, 3, 4, all the routers are in same broadcast domain. R1, R2, R3 and R4. R4. Let's suppose behind R1 I have a network 1.1.1 behind R2, 2.2.2, behind R3, 3.3.3.3, behind R4, 4.4.4. Why DR and BDR? See, router 1 will have how many neighbor? Router 1 is going to send a hello message on multicast address 224.0.0.5. Forget about the DR BDR. Now, let's suppose we don't have DR and BDR concept in OSPF. In that case, what happened? Router 1 is going to generate a hello message. It will send hello message on 224.0.0.5, and it will receive hello message from 3 other neighbor as well, from R2, R3, and R4. In active neighbor field, there will be 3 neighbor router information: 2.2.2, 3.3.3, and 4.4.4. It means router 3 has 3 neighbors: R2, R3, and R4. Similarly, R2 has how many neighbor? 3 neighbor: R1, R3, and R4. R2, then R3 has neighborship with R4, neighborship with R2, and neighborship with R1. This is my neighborship adjacency. How many neighborship adjacency are there?
Three.
All the routers has 3 neighbors, and I have 4 routers. So 3 multiplied by 4, 12 adjacency are there. How many adjacency? 12 adjacency are there total. In this scenario, when I have only 4 routers in one broadcast domain. Now imagine here on router number 1, any loopback goes down. What happens in this case? When our loopback goes down on router number 1, router 1 is going to update their database, right? It will remove one link. Let's suppose earlier in their router LSA there was 4 links. Now it is going to reduce it by 1, 3. It will execute SPF algorithm, and then it will update to their neighbors. It will update to their how many neighbors? It will update to their 3 neighbors. Now R2 has received one updated information from their neighbor. How it will track the information is updated or not? With the help of sequence number. With the help of sequence number, because once the loopback will goes down, or once a router is going to execute SPF algorithm, it will increment in their router LSA sequence number by 1. So let's suppose router 2 has a router LSA of 1.1.1 with sequence number 3 earlier, and now it is receiving router LSA with sequence number 4. It means it has some updated information. Router 2 is also going to update their database. It will execute SPF algorithm, and their sequence number will be also increased by 1. It will become 4. And router 2 is also going to update to their all neighbor. Oops. Router 3, who had received router LSA of 2.2.2 earlier with sequence number 3, now it is receiving with sequence number 4. It is also going to update their database, and it will share their router LSA, their database as well to all neighbor. Similarly, all the router, when again loopback interface will come up, again same thing will happen, right? Whenever any network is going to come up or going down, whenever router is executing SPF algorithm, if any change is happening in scenario on any one router, all the routers are going to execute SPF algorithm multiple times. And here you can see the LSA flooding. LSA flooding. It is similar like, let's suppose this is a classroom. 50 students are sitting in this classroom. How many students? 50. Let's suppose principal came and principal asked date. Hey, what is the date today? All 50 students are going to say, hey, today is, let's say, 14th July. What will happen in the class? Flooding, right? What will happen in the class? Flooding only if all 50 students are going to, today is 14th July, today is Sunday, Monday, whatever. How we can avoid this flooding in the class? By electing the monitor. That bro, one student who is brilliant in the class, you are the monitor of the class. When principal came and asked for the date, you will reply. if there is some notification, some message, you can get that from the principal and you can share with all students. If a student has any concern, a student can tell to monitor, monitor can pass it to principal. To avoid the flooding in classroom, we elect monitors. Similarly here, as all the routers are updating their database and informing to their all neighbors, we want to change this behavior to reduce the flooding, LSA1 flooding, even to reduce the number of adjacency. 12 number of adjacency is more when we have only 4 routers. If I have 50 routers in headquarters? What if this is a data center of Google? When we have hundreds of routers? My God. Right? So frequently CPU utilization of all router will be fluctuating here, right? Suddenly it will reach to 100%, 90%, and after some time it will reduce to 20%. Again, whenever any change will occur, all the routers are going to flood LSA1 and all the routers are going to execute SPF algorithm. To avoid this, what we did, we performed DR and BDR election. Now here, let's suppose router 4 is my DR router. I will talk about the election. Let's suppose R4 is my DR router. So, and all other routers are DR other. All DR other routers are going to form OSPF full adjacency with DR router only. With DR router only. This is full neighborship. And between DR others, you will have two-way neighborship. Right, like router 1 and router 2 are in two-way state. Two-way. Till two-way you have seen router is only exchanging what? Hello message, right? No any database, correct? This is what we have understood till now. In a state we have discussed down, we have discussed init, and we have discussed two-way. We are here at two-way state. Till two-way router is only exchanging hello message, right? Router 1 and router 2 will be in two-way state. Router 2 and router 3 will be also in two-way state, and router 1 and 3 are also in two-way state. It means now router 1, 2 and 3 cannot exchange database directly. What if this loopback goes down? Now R1 is going to update their database and it will send updated database to their neighbor. To which neighbor? To the full adjacent neighbor R4, right? It will send LSA1, new LSA1 with higher sequence number to R4. R4 is going to update their database and it will inform to their neighbor. Two more neighbors are there on router number 4, so it is going to advertise to R2 and R3. That's it. To R3 and R2. When R2 will receive the updated information, will R2 update to R3? No, because neighborship is in two-way state. So why we come up with DR concept? To avoid the LSA flooding and to reduce the number of adjacency in broadcast network type or in multi-access segment. But what if monitor is absent in the class? We need a backup monitor, right? Similarly, what if this DR router goes down? So for that we can have one BDR router also. Backup DR router. Backup DR router. Is it clear? Now tell me, between two routers, when R1 and R2, two routers are connected, is DR and BDR required? No. Where is the flooding? There's no flooding, right? When we have more than two routers in one segment and one network, then DR and BDR is required. When two routers are directly connected to each other, DR and BDR is not required. In this case, you should always change OSPF network type. Network type should be P2P, point to point. In this case, one router must be DR. Clear? Say yes or no, anything.
Sir, understood why we need to have DR and BDR. Sir, but another question. So DR, BDR basically is required to avoid the LSA flooding among the routers. Sir, in point to point, if there are updates being sent by R1 between R1 and R2 every now and then, uh, okay, will that also cause a kind of flooding if there are some networks that are fluctuating?
No. See, if there is any change, definitely R1 should update to R2, na?
Yes.
That
Okay.
is not flooding. There is only one router.
Okay. Okay, but if the interfaces on R1 and R2 are flapping every now and then, but they'll keep exchanging that updates.
Yeah, it should update, na? It should
Okay.
exchange.
Okay, fine. Now got it, sir. Got the answer. Why we need to change priority and when. Thank you.
Now question is, which router will become DR? So I will talk about DR and BDR more later. For now, I'm not going to discuss how DR and BDR election happens. By the way, in this case, see, for DR and BDR election, there are two things. Number one is priority, and second one is highest router ID. Router with highest priority will become DR. By default, priority is same on all the router. So based on priority, it can not perform DR and BDR election. So router with highest router ID will become DR. In this case, R4 will become DR. But R4 will become DR if you have configured OSPF on all the router within 40 seconds. Because you know timeout for our DR and BDR election time is 40 seconds only. Let's suppose on router number 1, I have enabled OSPF routing protocol. And within 40 seconds, I didn't enable OSPF on any router. So router 1 is going to wait for DR election. How long? 40 seconds. Within 40 seconds, if router will receive a hello message with higher priority or higher router ID, then good. Otherwise, after 40 seconds, router is going to declare their self as DR, that I am the DR. Now, once PM is elected, no one is going to change it. Once DR is elected in this segment, doesn't matter, later router is coming with higher IP address, router ID, highest priority or lowest priority. No one is going to replace the DR until and unless R1 will goes down. So for the election, even we can discuss this later as well. For election, highest priority, so that you can manipulate the DR, right? Because by default, in this scenario, R4 will become DR. But let's suppose R1 is my more powerful router, right? Has more memory, more CPU. So I want R1 should always become DR. I don't want R2 and R3 should participate even in DR and BDR election. Then what you can do, you can set priority 0. If you want any router to not participate in DR and BDR election, that router should be always DR other. You can configure priority 0. And one more thing, router will never become DR. Router interface will become DR because even OSPF protocol is running on the interface, right? So if I have a topology like this, see, first let me clear this: highest priority and then highest router ID. If 3 routers are there, R1, or even here I have a link between R2 and R5. So one DR and BDR is required over here as well between R2 and R4 if the network type is point to point, right? One DR and BDR is required over here and one DR and BDR is required over here. In each network, DR and BDR is required. But DR BDR depends on OSPF network type. In some network type, DR is required. In some network type, DR is not required. Like in point to point, DR and BDR election is not happening. In broadcast network type, DR and BDR is election is happening. When DR BDR election is happening, then these two are the criteria. And if you want any router to not participate in DR and BDR, you can simply set priority 0, so that router can not participate in DR election. like in my case here you can see between R1 and R2 config T, no router OSPF1, no router OSPF1. I've removed the OSPF and on the router number 1 do so run interface F0/0. Yeah, interface F0/0 network type. I'm going to change it to, I will show the DR and BDR practical later guys with multiple routers in one broadcast domain. Interface F0/0 no. And on router number 1 I'm going to enable OSPF router, OSPF1 router ID 1 and network 12.1.1 0.0.0 and area 0. After running this command, router 1 will participate in DR and BDR election, right? So IP OSPF interface fast Ethernet 0/0. Here you can see right now, right, network type is broadcast. In broadcast network type DR is required, and state is what? Right now state is waiting. It is waiting for DR and BDR, and it will wait for how long? Wait time is 40 seconds. It will wait for 40 seconds. Still waiting. After 40 seconds, it will declare itself as DR. It is waiting, right? Within 40 seconds, if router 1 is going to receive a hello message with higher router ID, then that router will become DR. Right? After 40 seconds, see, still waiting. And now router 1 has declared itself as DR, that I am DR. But router 2 has higher router ID. Router 2 should become DR. Now if router 2 will come up, it will not become DR. Router ID 2.2.2 and network 12.1.2 0.0.0 and area 0. So IP OSPF interface F0/0. You can see this router is BDR. Quickly, this router has declared itself as BDR. Reason, DR is already there. How router 2 got to know that? How router 2 got this information that DR is already elected? With the help of hello message of R1. Praful, you can check hello message of R1. In hello message, router also share the DR router ID, correct? Hello message of R1. Here it is. DR router ID. Right? Check the later hello message. Active neighbor, DR router. It is sharing the IP address of DR router and BDR router. When router 1 has received the hello message from R2, it got to know that router 2 is my BDR. So now router 1 is sharing BDR router ID information as well. DR is 12.1, BDR is 12.2. And default priority is 1. Even if I will configure priority 100 on router number 1, interface F0/0, IP OSPF priority 100, this router will not become DR. If you will clear the OSPF process, clear IP OSPF process, and in neighborship also you can verify it. So IP OSPF neighbor 1.1.1 is DR on router number 1. So IP OSPF neighbor 2.2.2 is BDR. If I'm going to clear the process, clear IP OSPF process, yes, then which router will become DR? R2 will become DR. So IP OSPF neighbor. Now you can see 2.2.2 is my DR. And now router 1 become what? BDR. If I will configure priority 110 on router number 1, interface F0/0 and priority IP OSPF priority 110, no, it will not become DR. So until unless DR will not goes down, no any other router will become DR. And if you want router 1 to not participate in DR and BDR election, like so IP OSPF interface F0/0 include state. So what it's saying, this router is BDR. If you don't want router 1 to participate in DRVDI election, you can set priority 0 over here. IP OSPF priority 0. But in this case, you should not set priority 0, right? This is for this kind of multi-access segment, right? Now you can see, so IP OSPF interface F0/0 include a state. What it's saying, state is DR other. It will not cause issue because still we have one DR router, right? R2 is my DR. So this is not the issue, but on both the router, if I'm going to set priority 0, it will cause the issue. Neighbors will be stuck in two-way state. Router cannot exchange the database and router will not have the route. This is two-way state. Let's move to the next state now. In two-way state, WAN router will move in two-way state, WAN router will find their own router ID. And in two-way state, routers are going to perform DR and BDR election. Next state is after two-way. Next state is, you can see, X start. X start state. In X start state, routers are going to exchange, guys. Very interesting state. Let me open another page. Fourth state, X start. See, OSPF is really amazing protocol. When you go to restaurant, let's suppose this is a restaurant. Table, and you are with your family in this restaurant. You came here and for dinner, let's suppose. So in this restaurant, what you will get first? You will get menu card first. Menu card. What menu card carry? What information menu card carry? List of all the foods. List of food that this restaurant offer. This restaurant has. If you need burger, you will request for burger, and after that you will get actual burger. In the restaurant, there are lots of things. But restaurant is not going to serve everything to you. Restaurant will only serve those food which you will request. Like if you will request burger, you will get burger. If you will request pizza, you will get pizza. Similarly, router has lots of things in database, but routers are not going to share everything to their neighbor. Whatever R2 will request to R1, R1 will give that, right? Because database size is lengthy, guys. This is amazing feature. So in X start state, router exchange the menu card of their database. That is called DBD, database description. Database description means the header of all prefixes present in my database. Header information, just a header, right? Summary information of all the prefixes. For an example, I have two router R1, R2, R1, R2. R1 has some prefixes here, 10.1.1.0, 10.1.2.0, 10.1.3.0. Router 2 has also some prefixes over here, 20.1.1.0, 10.1.1.0 /24, 10.1.2.0 /24, 10.1.3.0 /24. Right. Router 2 also has 20.1.1.0 /24, right? It has 20.1.2.0 /24, and let's suppose router 2 also has 10.1.3.0 /24, right? Maybe it is learning from another routing protocol which is better than OSPF, right? Router 2 has better path to reach in 10.1.3.0 rather than reaching via router number 1. So after enabling OSPF, router 1 is going to store all link information, all the detailed link information in their database. That is called link state database, LSDB. Similarly, router number 2 also has a link state database where it has stored the detailed information of link. Correct? In the database, there is information of link 1, link 2, link 3, and so on. Similarly, in the database of router number 2, there are all link information. And now 2 routers has become neighbor. Both becomes neighbor. Let's say they are in two-way. In two-way, they have performed DR and BDR election, and now state move to X start. Router 1 is going to send a database description. This is where router are going to exchange the sequence number. Where router are going to exchange the sequence number through DBD, database description. In the database description, it will carry the summary information of all the links, similar like the menu card of a restaurant. Inside this database description, router 1 is going to tell to router number 2, bro, I have 10.1.1.0. I have 10.1.2.0. I have 10.1.3.0. Do you need any prefix? Router 2 is going to say, bro, I already have 10.1.3.0 and that is best. So I only need these two one. Similarly, router 2 is also going to send their database description that, bro, I have 20.1.1.0, 20.1.2.0, 10.1.3.0. Router 1 is going to, bro, I already have 10.1.3.0. I only need 20.1.1.0 and 20.1.2.0. Note in the X start state. In X start state, both the routers are just going to exchange DBD. Empty database, header of database, similar like the menu card of restaurant. Now, here with the help of DBD, both the routers has exchanged one thing which is very important for tracking. For tracking, like both the neighbors can track each other, that is sequence number, right? Maybe in the DBD of R1, sequence number is going to be 1. Sequence number will get exchange. Number one thing. Number two thing, MTU size will be negotiated. If you don't want router to negotiate the MTU, simply you can say ignore MTU, right? Router OSPF1 and ignore MTU. Ignore router OSPF1 and MTU IP interface F0/0 IP OSPF MTU ignore, like this, right? Then it is not going to negotiate MTU. By default, it negotiates MTU. It also performs one thing, that is master and slab election. Like DR and BDR, in X start state, routers are going to perform master and slab election. Why? Only for one reason. There is no other reason of master and slab. So that both the routers can decide which router will start sharing, exchanging database. Whoever will become master will start exchanging database first. And for master and slab election, what happened? We have same concept like DR and BDR. Okay, you will learn later as well. This is third thing. And fourth thing is
So class is too long, sir.
What happened? Hello? What are you saying?
I think he was saying like too long of a class.
Oh, it's 10 and sorry. Let me finish it quickly. Okay. See, last thing is empty database DBD. Empty DBD will exchange. And after these all things, your state will move to exchange. Your state will move to exchange. And actually in exchange state, the header, like I said, like the menu card, the DBD will get exchanged in exchange state, not in access start state. In access start state, they have not exchanged even the header. They have just exchanged the empty MTU to negotiate the sequence number, to negotiate the MTU, to exchange the sequence number, to negotiate the MTU, to perform master and slab election, and that's it. These four things happen in access start state. Then neighborship will move to exchange state. In exchange state, both the routers are going to exchange the headers, LSA headers. And then after LSA header exchange, your state will move to loading. And in loading state, routers are going to generate main message of OSPF LSR, link state request, LSU, and LS ACK. And when LSR, LSU, and LS ACK is exchanged, then your neighborship will move into full state. So when neighborship is in full state, it means what? It means entire database is already exchanged, updated. Right? Everything is updated. Now let me take you to the types of message. First message was hello message. Can anyone tell me in which state OSPF router exchange hello message? In which state OSPF exchange hello message?
Two states,
In
sir.
all state, from down to full. Even when neighborship is in full state, then also OSPF routers are exchanging hello message for keep alive message. Type 2 message was DBD message. In which state OSPF exchange DBD message? In X start and exchange state. In which state OSPF exchange LSR, LSU, and LSAC?
Loading.
In loading state. And in full state, only hello message. That's all for today, guys. Thank you so much. Now, if anyone have question, you can ask. If anyone is in hurry, you can leave. Now, I'm not going to discuss any new thing today. We'll continue from here tomorrow. If anyone has doubt from what we have discussed, you can ask. Tomorrow, we'll understand, we'll revise these all things with LSC as well, right? Tomorrow, we'll introduce the LSAs in OSPF, and after that, we'll take it further. So this was the basic of OSPF, right? Here I have talked about EIGRP, limitation of EIGRP, then SPF algorithm, cost calculation. After that, we talked about types of messages, then hello message, and states, OSPF states, two-way state, DR, BDR, master slab, and OSPF router ID, nothing else. Only basic of OSPF routing protocol. But still, if anyone have question, please ask. Hello. All clear?
All clear, sir.
Great then okay, that's all for today. We'll continue from here tomorrow. I'm going to share the recording, and I have just enabled OSPF on router. So whatever I have tested in today's class, if possible, you should also test that, right? Try to configure priority 0 between two router, try to change the OSPF network type, and try to see the neighbor table, right? The database table once. Even if you are not able to read the output, that is absolutely fine. Just practice it, basic. If you don't have time, no worry, you can leave it as well. Later we'll see. When I will start the actual OSPF configuration, at that time I will also give you the labs. In OSPF, after every topic, I will be giving you the lab. So you need to configure those labs also. Because after OSPF and BGP, we are going to combine multiple protocols, technologies together. And in same lab, we need to configure OSPF also, BGP also, right? MPLS things also, VPN also, NAT PAT also, right? So that is going to be complex lab. You can only configure those kinds of lab when you have practiced all small individual labs.
Okay, sir.
Okay, guys. Okay, great.